Okay, now let's look at a macroeconomic example of a production possibilities model. This is the exact same problem or presentation from the McConnell textbook. First, let's identify our two products in question. Pizzas. Remember earlier I said pizzas represent all consumer goods. Now, what is it about consumer goods? Consumer goods satisfy wants directly and immediately. So they satisfy our desires directly and immediately. The other product here are industrial robots. So these are capital goods, manufactured aids and tools used in the productive process. So they could be machines large and small, they could be software, they could be computers, any piece of capital used in the economy. Now, what's unique about capital goods? Capital goods satisfy economic desires or economic wants indirectly and over time. So, you might think that consumer goods are better because they somehow satisfy our economic wants directly and immediately, but remember, we're going to need to produce in the future. So we probably don't want an outcome of all consumer goods or all capital goods. For simplicity, we identify 5 points along the curve. Conveniently, we label them A, B, C, D, and E. Let's look first at points A and E and talk about what's going on with those particular outcomes. At point A, society is producing no consumer goods, no pizzas, producing all robots. So all land, capital, labor, entrepreneurability is being dedicated to the production of industrial robots or capital goods. The cost of such a choice is that there's absolutely no consumer goods. Let's shift over and look at point E. At point E, the opposite is taking place. At point E, this particular economy, this society is producing all pizzas, so all consumer goods, and no industrial robots, no capital goods. Think to yourself for a moment, why are A and E, even though they're on the production possibility curve, not realistic outcomes? Neither one of these could be allocatively efficient, the proper combination of goods and services most desired by society. The reason why neither one of these could be allocatively efficient is simple. We can't live in the world of possibility A. We need for certain food, shelter, and clothing. Therefore, we need consumer goods. So we can't produce all industrial robots. Likewise, point E. In the future, we're going to need additional machines and tools and manufactured aids to produce products and services. Therefore, E is not a realistic, allocatively efficient point. However, we leave them here because it helps us with our discussion. Okay, let's also talk about this idea of costs and trade-offs and opportunity cost along the curve. Remember in the Sarah study world where we had a linear production possibility frontier, the cost along the curve were constant. This is not going to be the case when we study a macroeconomic example of a production possibilities model. In this particular production possibility frontier, we're going to demonstrate what is known as the law of increasing opportunity costs. So we start here at point A and say, okay, society is making no pizzas, no consumer goods, all robots, 10 capital goods. But we're not too happy with that outcome. We're going to shift some of our land, capital, labor, and entrepreneurability away from producing robots and into the production of pizzas. Lo and behold, pizza production goes up by 1, so we get 1 additional consumer good. But what's the cost? Because remember, we can't have more of both simultaneously. That's just not economically feasible because of absolute limitations of production. So when we produce that first consumer good, that first pizza, we had to take resources away from our good old robots. So you can see that the cost is we're producing 1 less robot. So the opportunity cost of this first level of pizzas is 1 robot. Economic thinking is marginal thinking. We are now at point B. Let's say we want to shift more resources into producing consumer goods and away from capital goods. As we move from B to C, we gain an additional pizza, an additional consumer good, but look what happened. This time it cost us 2 capital goods. And if we move from C to D, again we gain an additional pizza, an additional consumer good, but this time it cost society 3 capital goods, 3 robots. And finally, that 4th pizza cost society a total of 4 robots, 4 capital goods. The big question is why? So we've identified what is known as the law of increasing opportunity cost. Each successive choice costs more than the previous choice. In other words, the first round of consumer goods only cost 1 robot. The second cost 2, then 3, then 4. Why? What's different here than the Sarah study world? Well, Sarah was one person performing 2 highly similar tasks, studying. In the real world, when we're talking about production of vastly different products, in this case, consumer goods versus capital goods, even though we're putting to use all of our available resources anywhere along the curve, resources in the short run are not readily adaptable, changeable, or intershiftable. Therefore, the law of increasing opportunity cost is avoidable. So, if we start at point A and we say, okay, we want to produce some consumer goods, some pizzas. Well, there's been some people working in the capital good world, industrial. So the reason why the law of increasing opportunity cost exists in the short run is because over that fixed period of time, for instance, a month or a year, economic resources are not readily adaptable, shiftable, or interchangeable between these vastly different products. Capital good production is quite different than consumer good production. So if we look at point A on the curve and say, okay, at this point we're not making any pizzas, no consumer goods. We're making all robots, 10 robots. When we shift some land resources, some capital resources, some labor, and some entrepreneurability away from robots and into pizzas, there's going to be some people who can quickly adapt, so the opportunity cost isn't that high. There's going to be some machines that could be utilized quickly to produce consumer goods that can be easily refurbished or retooled to produce something different. But the second round, in other words, when we want more consumer goods, more pizzas, it gets more difficult to pull off this little trick, right? So we might have to send some people back to some type of educational school on how to become a better pizza producer or consumer producer. We might have to take apart entire warehouses or factories that produced formerly capital goods that are now producing consumer goods. Now, the law of increasing opportunity cost exists whether we're moving away from capital good production into consumer good production, or we're moving from consumer good production into capital good production. So it doesn't matter which way we move along the curve, the law of increasing opportunity cost is going to exist whenever we study a macroeconomic example of production possibilities frontier. Let's demonstrate this mathematically, moving from E back towards A. If we're at E, society is producing 4 consumer goods, 4 pizzas, and no industrial robots. We already said before, this is probably not the best possible outcome. So as we moved and shift resources away from pizza production, consumer good production, and into industrial robot production, capital goods, what happens? Well, consumer production goes down. Industrial robot production goes up. How much did it cost us to produce these 4 industrial robots? Well, we had to give up 1 pizza. So therefore, each robot cost us 1/4 of a pizza. Now I'm going to show you an easy way to remember this. Whatever you're getting, in this case we're getting capital goods, we're getting robots. Put that on your denominator, the bottom of your fraction. whatever you're giving up, put that on your numerator, the top of your fraction. So in total, we gave up 1 pizza to get 4 capital good robots. So 1 over 4, each robot cost 1/4 of a pizza. If we perform that same exercise moving from D to C, what happens? Well, again, in total we had to give up 1 pizza. This time we had 3 additional robots, 3 additional capital goods. So therefore, each robot cost what? Well, we got 3. That's what we're getting. We put that on the denominator. Gave up 1. Put that on the numerator. 1/3. 1/3. So from E to D, each robot only costs 1/4 of a pizza. From D to C, each robot costs 1/3 of a pizza. And trust me on this, if we went from C to B, it would be 1/2 of a pizza. And then from B to A, it would be 1 whole pizza. So the opportunity cost of each successive choice is getting higher, aka increasing marginal opportunity costs. So we began examining the production possibilities frontier, the production possibilities model, by looking at the data of pizza production and robot production and 5 points identified on the curve. Now we need to graph these points to look at this same information and to learn some economic lessons from the graph. I think any 5th grader could handle this. We simply take robots, put them on the vertical axis, pizzas, put them on the horizontal axis, and we just fill in the points, right? So this would be point A, B, C, D, and E. Notice now we have our completed production possibility frontier. Before we do anything further, let's review an important idea. And this is why the graph is such a powerful tool. The 4 economic lessons associated with studying this model. Absolute limitations of production. For the time being, the society that we are examining cannot do any better than along this curve. This is the absolute maximum level of production that can take place for the time being, given our fixed resources, fixed technology, and full employment of those resources, assuming productive efficiency. So anywhere along the curve is possible outcome, right? That's limitations. Next, the idea of trade-off in costs. If we are producing all robots and we want some pizzas, well, we can't have more robots and more pizzas simultaneously. If we want more robots, the opportunity cost of more robots is giving up pizzas. If we want more pizzas, the opportunity cost is giving up robots. So if we're at point A and we say, okay, we're producing all capital goods, no consumer goods, but we want some consumer goods, we can only move towards B, that is producing some or more consumer goods, by giving up some industrial production, some robot production, some capital goods. And again, if we want more consumer goods, we're going to have to give up additional units of capital goods. Also notice that this production possibility frontier is actually a curve, aka the production possibilities curve, not like the Sarah study world. You don't even need to perform the math that we just did on the previous few slides to calculate increasing opportunity cost or to demonstrate it. If a production possibility frontier graphs as a curve, if there's concavity to it, you automatically know that increasing opportunity costs are present in this particular situation. Okay, what else is going on along this curve? What about this yellow area in here? What does it say? Attainable but inefficient. So there are times when society does not use all of their available resources. They do not achieve full employment. And they may be producing at a point close to here or close to here. So they're operating inside the production possibilities curve. Any point of production inside the curve is attainable but inefficient. Why? Well, If we're producing at a point, say close to here, look, we could be having more consumer good and capital good production. Any point inside the curve means we could be doing this, but we should be doing better. In macroeconomic sense, a point inside the curve actually represents a recession, a time in place when an economy is underperforming, not putting to use all of your available resources. Never too early to learn some important real-life applications of this model. Therefore, if we're at a point inside the curve, the unemployment rate in the country is going to be well above the average or normal or expected unemployment rates. There are also probably some capital goods that are not being used. In other words, some machines, some factories that are laying idly, not being put to full use. What about this point, W? W for wishful thinking, right? We'd all love to produce a W. Sure, that'd be great, right? Because right now, the best we can do is D. That's pretty close to W, right? That's the best we can do with our limited land, capital, labor, entrepreneurability, right? Limited land, capital, labor, entrepreneurability, and our fixed resources, right? Our fixed technology. We can't get beyond this frontier, this curve. So, W represents our last idea, economic growth. More about this in the future. How do we achieve economic growth? We're going to talk about that real soon. But in order for an economy to produce and consume at a point near W, we would need to achieve economic growth. All right, I'm going to leave you with a question. If you wish to, you can pause the video before moving on to answer this. But what point on this particular production possibility frontier is allocatively efficient? What's the proper combination of goods and services most desired by society? Well, we know it's not A because we can't have all capital good production and no consumer goods. We know it's not E. Can't have all consumer goods and no capital goods. So it leaves you with three choices, B, C, and D. Think about it for a moment, and then we'll talk about it more on the next slide.